Hey there, this is Miss Townsend, and I love math. Welcome to Math with Townsend. This is a grade 10 academic summative. We've been looking at question 3, and this is actually part 3, so video number 3 that's taking up question number 3. It's quite a question. So we started by drawing a triangle with vertices PQR, and then we had to find the equations of the medians. So that's all in video 1, and when you find the equation of a median, part of that process is to find midpoints. So I've shown the midpoints on this diagram. I've got J, which is opposite Q, K opposite L, and L opposite P. So those are my midpoints. And then in video number 2, we did this, determine the coordinates of the centroid. So the centroid is shown in the diagram with labeled point C, and we found that coordinate by algebraically finding the intersection of those median lines. And now video 3, we're going to look at part D. So let's see what it says. It says show that the distance from the centroid to each vertex is twice as long as the distance from the centroid to the median on the opposite side. Okay, so let's make sure we understand clearly that when we have a vertex, so let's look for example at vertex Q, there is a related midpoint on the opposite side. So Q is always connected with J because it doesn't make sense to connect it to K because then why would you be ignoring L? So we connect Q and J kind of have this relationship. So Q is opposite to J, and this question says, show that the distance from the centroid to the vertex, so from C to Q, show that this distance is twice as long as the distance from the centroid to the midpoint on the opposite side. So in other words, show that CQ is twice as long as CJ. So I'll write that down. I will need to show that CQ is twice as long, is twice as long as CJ. That's what I'm trying to show. And obviously there's other vertices. So I'm also supposed to show that CP is twice as long as CL. So here that is CP and CL. And I'm supposed to show that CR, so that's the third vertex, is twice as long as CK. So those are the three things I'm supposed to do in this question, all of which involve finding distances between points. So let's start here. This is a summary of all the information I'm going to need. PQR are the vertices, and I've lined them up opposite their midpoint partner, if you will. This is the coordinates of the centroid we found in video 2, and of course this is the distance formula which we're going to have to use. So let's start with PL. So we need to show that the distance from CP is twice the length CL. So let's find the distance from C to P. So using the distance formula, so I have x2 minus x1 squared plus y2 minus y1 squared. So here we go. Now here I have to deal with this bracket before I do the exponent. That's bedmas. And so what I have in the bracket is a fraction, negative 5 over 3, subtract a negative. Well, we know that subtract a negative actually means add. And if I'm adding and one of the numbers is a fraction, I must get a common denominator. So I'm trying to add 5, so I'm going to turn that into 15 over 3. You guys know this stuff, I'm just reminding you. 1 minus 1, okay, that's easy, 0. So let's keep going. In the first bracket, I know I have a denominator of 3. Then I have negative 5 plus 15, so the numerator is 10, and that's going to be squared. And 0 squared, I'm pretty sure I know what that is. So look what I'm left with. I'm left with 10 over 3 squared square rooted. So squaring something and square rooting something is pretty pointless. They just cancel each other out. So I'm left with the distance of 10 over 3. Now, I don't know if your teachers are going to allow you to write this in decimal notation or not. I'm going to assume that they're not, just in case that's something you need to see. I obviously don't need to show you how to, write decimals. So there's the distance from C to P. So now I'm going to draw a line, try to organize, even though I know it's a little messy. Now we need to find the distance from C to L. So again, distance formula. So again, x2 minus x1, which in this case is 0, that's kind of nice, plus y2 minus y1. So I started with this one because I knew that the numbers would be a little easier, just to get a feel for what's going on in this question. So negative 5 over 3 minus 0 is just negative 5 over 3. And again, 0 squared, that's going to be nice to work with. So kind of like above, I'm left with the square root of something that I'm squaring. Oops, that's a 3. So how do as we discussed above, square rooting and then squaring are kind of redundant operations. However, let me put a nice giant red little asterisk here because I want to make sure you hear this clearly. That what does happen, however, is if we were to go through this process, squaring negative 5 over 3, we would get a positive number. And then we could square root that positive number. So even though squaring and square rooting are kind of redundant opposite operations, make sure you know that they do turn a negative number into a positive number. So there's the distance from C to L. So let's summarize what we have in this question. So we have the distance from CP, and that was 10 over 3. We have the distance from CL, that was 5 over 3. So hopefully you can see, it looks good to me, but let's communicate properly. So CP is equal to 10 over 3, which is equal to 2 times 5 over 3, which is equal to 2 times CL. And that's what I wanted to show, that the distance from C to P was twice the length of the distance from C to L. Now I'm going to teach you something fancy if your math teacher hasn't already. In math, when we have shown something that we were trying to show, in other words, we finished doing a good proof, there's something that we say. We say quod extra demonstrato. Now I know I probably said that way wrong. I don't speak Latin. But, that's okay. I know the shortcut. QED is the math shortcut for hurrah! I did what I was supposed to do, and I showed you what you wanted, so I'm done the question. So I always do QED smiley face. But again, that was only one of the 3 parts to this question. So let's do this one, and then we'll probably leave the other one for you to do on your own because it's an awfully long question. So again, we need to show that C to Q is twice the distance, not the same distance, as CJ. So again, x2 minus x1 squared plus y2 minus y1 squared. So again, follow the rules of algebra. Look at the bed myths. This bracket here has to be dealt with before I square anything. And inside that bracket, I have negative 5 over 3. Subtract the negative. Well, that's plus. And then this 3, I have to turn that into something with denominator 3 because I have a fraction over here. So this will become 9 over 3. So again, minus a negative becomes a plus. 3 over 1 is equivalent to 9 over 3. And now I have that common denominator. And over here, 1 minus 5, that one I got, no problem. That's negative 4. So first bracket, I know the denominator is 3. Negative 5 plus 9 is 4. And then negative 4 squared. You know what? I'm going to wait and do that on my next step so that I'm not out of sync with what I'm doing between my 2 brackets. So here's the next step. I'm going to square 4, and I'm going to square 3. And then negative 4 times negative 4, boy, that sure turned out messy. Oh, you know what I mean, is 16. So again, a square root sign is kind of like a giant bracket. You need to resolve the bracket before you do the square root. So again, I'm adding and a fraction's involved. So I need to turn 16 over 1 into something over 9. So that would be 144 over 9. So common denominator is 9, and it's 160 over 9. Now here, I'm really not sure what your math teachers would have done with you this year, because they may have said just turn this into a decimal, which of course you don't need me to show you that. So I'm going to pretend that they want you to do like the hardest, fullest extent of the math you can. So let's keep going, and I'm going to assume that you're not allowed decimals, so you have to be very mathematical. And I'm just going to change color pen so that you know that this is the point where it depends on what your teacher really wants. Because what I'm about to do is definitely the tougher, the tougher route. Getting a decimal is very easy. Use a calculator. But this is good math too, and maybe you want to see it, and maybe your teacher really wants you to know this stuff. So I take the square root of 160 over 9, and I turn it into the square root of 160 over the square root of 9. Now, the square root of 9, we know that that's 3. But the square root of 160, well, we're not going to start using a decimal when we're purposely avoiding it. So instead, we're going to say that 160 is 16 times 10. And 16 is an important number because you know that 16 is a perfect square. So that means on the numerator, I can write the square root of 16 times the square root of 10. 10 is an ugly number. I can't square root it. But the square root of 16, you should know that. The square root of 16 is 4. So what I end up with is 4 root 10 over 3. So this stuff in blue ink, again, I'm not sure how much you would have covered that this year, but there it is. So the perfect answer is 4 root 10 over 3. The imperfect answer, well, you can get that on your calculator. So all of this was to get CQ. Now I need to find CJ. So let's find CJ. And again, distance formula. So x2 minus x1. Have to remember what the points are. So x2 minus x1 squared plus y2 minus y1 squared. So there's CJ. And again, I'm just going to do the algebra like before. First bracket, negative 5 over 3 minus a negative is a plus. And 1 has to become something with denominator 3. So that's obviously 3 over 3. Here, 1 minus negative 1 is 1 plus 1, or 2. So negative 5 plus 3 is negative 2 over 3 plus 4. So now I can square that fraction. Negative 2 times negative 2, 3 times 3. So I have 4 over 9. Keep going. Again, remember the square root sign acts as a bracket. So before you take the square root of anything, you need to deal with this addition. So I need to get a common denominator again. My common denominator is 9. 4 times 9, so that would be 36 over 9. So I get square root of 40 over 9. And again, this is the point where if your teacher's okay with decimals, turn this into a decimal and you're basically done. I'm going to keep going and show you the more formal math that you could do, just like in CQ. So what do? Well, we know that I can write this as root 40 over root 9, and that's nice because we know the square root of 9 is just 3. But what do we do with root 40? Well, I need a perfect square. So 4 is a perfect square that I can use because 40 is just 4 times 10. So that means I can write the numerator as square root of 4 times square root of 10. And don't lose that denominator, it's still 3. So now the square root of 4 is 2. So this is 2 root 10 over 3. So that's the length of CJ. So again, we had found that the length of CQ was 4 root 10 over 3. And the length of CJ was 2 root 10 over 3. And again, hopefully you see we've done the right math. So we can write that CQ is 4 root 10 over 3, which we can write as 2 times 2 root 10 over 3. And 2 root 10 over 3, hey, that's CJ. So I've shown that CQ is twice the length of CJ. And like we said before, let's put a little QED happy face. Now I don't have time to do CR and CK, so I'm just going to have to let you do that on your own. Obviously, come and ask for help if you need it. But I hope that you understand at least how to do this question. And I'm so glad that we are finally done question 3. Big happy face, big kind of weary face. Uh, uh, too long. All right, good luck on your math. See you in school.